All right, we are on lesson 55, solving systems of linear equations by graphing. So first, we probably need to know what a few things are. A system of linear equations. Okay, what this is just two or more equations with two or more variables. So two or more equations with two or more variables. In this case, we usually use x and y, sometimes z if we're getting really crazy. Okay, so then a solution to a system of linear equations is an ordered pair that makes all the equations true. So a solution is an ordered pair that makes all equations true. It has to work for all equations. Okay, so first let's just talk about identifying solutions. So in this case, they're going to give you a set of equations. They're going to say, hey, here's a point. Does this point solve all these equations? So for identifying solutions, my bad. Okay, now, so for our first example, they're going to give us two equations. The first one is 3x plus 2y equals 7. And the other is x equals 7 minus 3y. They're going to say, okay, we're going to give you the point 1, 2. Does that point solve both equations? So all we're going to do is plug in 1 and 2 for x and y. So let's give it a shot. We've got 3 times 1 from this point over here plus 2 times 2 equals 7. 3 times 1 is 3, 2 times 2 is 4, 3 plus 4 equals 7, so it is true for that equation. Let's try it in this other equation. So we've got, replace the x with a 1 equals 7 minus 3 times, replace the y with a 2. 7 minus 3 times 2 is 6. 7 minus 6 is 1, so it is true for both of these. So we would say, yes, this is a solution. So the ordered pair 1, 2 is a solution to these equations. If it doesn't work, we would say not a solution. Okay, so let's try another example of this. We've got the equation 3x plus 2y equals 12. And the other equation is x equals 7 minus 3y, so the same one from up above. So x equals 7 minus 3y, and our point is going to be 2, 3. So we're going to check if 2, 3 solves both of these equations. So let's plug in the numbers. 3 times 2 plus 2 times 3 equals 12. 3 times 2 is 6, 2 times 3 is 6, and 6 plus 6 equals 12, so it works for this equation. Let's try the other one. X is 2 equals 7 minus 3 times y is 3. So 2 equals 7 minus 9. 2 equals 7 minus 9 is negative 2, so this is not true. So this is not a solution. If you want to be specific, 2, 3 is not a solution. Okay, so that's identifying solutions when they give you two equations and then they say, hey, here's the ordered pair. Okay, we can also solve these problems by graphing each equation and checking where the graphs cross. So let's take a look at what that would look like. We've got the equation y equals x plus 3. Well, let's label this back up. Solve by graphing is what we're talking about now. Okay, so in this example, we have the equation y equals x plus 3, and the other equation is y equals 2x plus 1. Okay, so this is in slope-intercept form, so that is going to make it pretty easy for us to graph these. Get a coordinate plane going for us here. Put my little arrows. Okay, so things we know because of slope-intercept form. Slope-intercept form is y equals mx plus b. M is the slope, and b is the y-intercept. So in this first equation, remember just having an x is like having an imaginary 1, so the slope is 1, and the y-intercept is 3. So it crosses the graph at y equals 3. So if we go up 3, that's going to cross the graph at that point. And then we can go up 1 over 1 to get to another point because of the slope. So we keep doing that. Let's just get a few points here. Draw our line. There we go. That is the line for our first equation. So now let's look at the second equation. We know the slope is 2, and we know the y-intercept is 1. Now remember, slope is rise over run. So in order for m to be 2, that means it's actually 2 over 1. So it goes up 2 to the right 1. So y-intercept is at positive 1. So we're going to put a point at positive 1. Then we're going to go up 2 over 1 to get to our next point, up 2 over 1 to get to our next point, up 2 over 1 to get to another point. If we draw this line, these two lines cross at a single point right here in the middle. That is the solution. So that point right there is 1, 2, and it goes up 1, 2, 3, 4, 5. So that point is 2, 5, and that is the solution to the set of linear equations, or the system of linear equations. And that is how we find solutions by graphing. You just check where the two lines cross each other. If the two lines never cross, we would say no solution. So that is solving by graphing. One last thing, sometimes the equation they give you will not always be in slope-intercept form, so if you want to graph it, you might have to rearrange it a little bit. So let's just look at what that looks like. So if we have the equations 3x plus y equals 9 and x plus 2y equals 8. We want to figure out what's the solution to this equation, so we want to get this in slope-intercept form. Now, remember, slope-intercept form is y equals mx plus b. So we got to solve for y basically here. So if I want to get y by itself in this first equation, I'm going to subtract the 3x over to the other side. Now, 9 and 3x are not like terms, so we have y equals negative 3x plus 9, because that 9 is positive. Now it's in slope-intercept form. Over here, if we want to get y by itself, we're going to subtract x. We get 2y equals negative x plus 8. We still need to get rid of this 2, so we're going to divide everything by 2 on both sides. So this is y equals negative x over 2 plus 8 divided by 2 is 4, which you can also write as y equals negative 1/2 x plus 4. So if it's asking you to solve a system of linear equations and they're not both in slope-intercept form, you can do a little bit of rearranging before you graph it, and then it becomes a lot easier for you. Alright, so today we've talked about how to identify solutions of systems of linear equations. That's when they give you these 2 equations, and then they say, hey, here's this point, check if it works for me. We also talked about solving by graphing. So that's when they give you these 2 equations and you're going to graph them and check where they intersect or where they cross. And that is the solution. If they don't cross, remember there's no solution. So if they don't give you the equations in slope-intercept form, we talked about how to rearrange everything to make that easier for you. You should have everything you need to go ahead and get started on your work. Make sure you ask questions if you need to, and I will see you in class.